Hello, I'm Max from 7th Memory, and welcome to our first devlog. If you didn't see last week's video, as a quick reminder, we're building an RPG where the combat is based on minigames and the gameplay changes with your story choices. In this video, we're going to talk about some of the overworld systems we've built, as well as what I've been up to. As for what I've been up to since the last video, I've been working on the moveset for Zhara, or at least a very basic one, and at least just trying to get all the skills put in. I also worked a lot on the infrastructure behind it, which isn't too exciting, but it means that we can do things such as have generalized functions that can map to movesets. This means that skills can override parts of your moveset if possible, instead of just augmenting them. This allows us to do a lot of different things, such as giving some characters the same moves without requiring excessive code, as well as just making it more generally scalable and modifiable. I also worked a lot on making the movement fluid and more smooth. In testing, an issue we've run into is that oftentimes attacking will kill your momentum. To help with this, I added some acceleration and deceleration, and I plan to add a little bit more user input, changing the way that you move. All of this is just so it feels more fluid to control, and it's going to be something that we're going to keep iterating on within the coming weeks. In addition, a big thing I worked on Friday was overhauling our movement code. Before, it looked like a huge mess all in one file, and it was kind of hard to parse. In order to fix this, I added a state machine to the player object and moved all the code into states. This makes it a lot easier to manage, as well as see the different things that you can do based on the state. And it also allows us to do neat things, such as allowing you to carry an item while also grabbing an item from a chest or reading a sign. Lastly, one of the big things I worked on was the movement correction. To explain this issue, when we've been playtesting the overworld movement, one of the things that we've noticed is that sometimes you'll get caught on surfaces by a few pixels, just being a little bit off from going around it. In games like A Link to the Past, you're often pushed around the obstacle in order to go to where you want to go. In order to fix this, I looked online. I'm essentially a monkey banging rocks together, so I wanted to see what other people had to say about this issue. My first attempt at solving this issue was something I saw a lot online. People often said just add a circle or capsule collider to the object and you'll slide around. When I tried this, however, it didn't really work as expected and sometimes had the opposite effect that I would want. I'm assuming this is partially due to the pixel perfect nature of the game, where perfect circles aren't really possible. While browsing, I found another post trying to solve the same issue, but in this one there was a different suggestion. One user suggested adjusting the square collider around tiles to be more circular. After trying this, it kind of worked, but sometimes you would still get caught. I'm assuming due to the same issue that was faced in my first attempt. After messing around with it for a while, I decided that 1, the solution was kind of overcomplicated and easy to forget about, and 2, that it didn't even work part of the time, which kind of defeated the entire point. From here on, I was ready to kind of throw in the towel for a little bit, but I had an idea. My first idea was to try to predict where the player would want to go, and adjust their movement accordingly in order to slide them around the object to go where they wanted. To do this, I knew that I would need 2 ray casts. In our player object, we have a variable called snapping distance. This is used for things like ladders, but it also could work here. Essentially, we want to have a raycast on each side of the collider to detect which side the collision is happening on. If one raycast is colliding and the other isn't, then we know the player is stuck on an object on one side, so we can adjust their velocity accordingly. If a raycast is colliding on one side but not the other, then we generally know which way the player wants to go. So using this, we can probably easily predict where they want to go based on where they're stuck, right? Well, it really wasn't so simple. In trying to get the predicted position and the position of where the player was stuck, it was pretty difficult, and the math was kind of just too much and too complex and kind of a headache to figure out exactly what was going wrong. I was almost ready to give up after this, but then I stumbled upon a Stack Overflow thread which inspired me to try one more solution. For a completely unrelated problem, a user mentions using normals. While I misinterpreted this and tried to implement their solution even though it wasn't relevant and I didn't read, it would help in the long run. Raycast and Godot have a method to get the normal of the collision that just happened. Using this normal, we can subtract it from some diagonal movement in order to figure out which way to slide the player, based on which raycast is colliding, as well as the direction of the collision. After trying it out, this worked almost perfectly. One of the issues though, which was present in the other attempt, is that you'd kind of get stuck on the corner. To work around this, I just kept the temporary sliding direction as your normal direction. And then, as you can see in this gameplay footage, it works pretty perfectly. It's not exactly perfect yet because there's this weird bumping issue which I have to figure out, but it works pretty okay, and it's a decent solution to the problem. There's still some issues with it, such as like diagonals, but at least for now, it's an okay solution. Now to move on to some of the map making tools that we have in this game, one of the things I'll talk about are flags. Generally in programming, flags are variables that you would set to indicate that something has happened or is at a certain state of an object. While the name might be a little misleading in our game, we have flags function as kind of areas that cause something to happen. So with our flag script, we can represent the bounding sizes of rooms, and that supports camera movement between them, as you can see in these clips. The camera movement isn't exactly perfect, and I want to eliminate having the little room transition flag in the middle, as you can kind of see the overlapping area 2D, but that's something I plan to fix a little later, and something that shouldn't be too hard, and I would like to be able to support multiple rooms. Moreover, this class also provides ladder utility for our game. Ladders in our game are kind of stupid. They're mostly an object that just has the flag thing over them, and in the player state machine, you just kind of snap into there and you move directly up or down to the next area. However, it supports the change in height, which allows us to be able to build multi-leveled levels. Moreover, it also provides a stair utility. I still have to do a little bit more work on this one. I didn't fully re-implement it when I was editing the state machine, but it's something I plan to do and something that shouldn't be too bad in the future. Moreover, our flags are able to set the music in the level, play dialogue when you enter, as well as change the world when you enter them, and they can be set to only activate once. The last object I'll talk about as part 1 of our overworld management is the door class. So it's kind of unfinished since we don't have shops implemented yet, and doors will be able to lead to shops, but generally they are able to function. Now, doors are area 2Ds that don't necessarily require a sprite, and basically how they work is that they're assigned a 2 map, which maps it to a certain prefab that we have that represents the room. In addition, they also have an ID in order to connect with other doors in that room. They're also able to pick a specific transition from our transition class, which we will go over in a general utilities video, and there are some configurations for this transition, such as following the player for certain ones, and you can also set the exit direction of the door, as well as toggle if it's a shop or not. Right now the shop functionality doesn't work, but it will in the future. Basically, whenever you enter a door, the transition will play and then the screen will be black. During that time, the current room is unloaded and the new room is loaded in, and then the other transition for the other door happens, and then you're able to move again. It's pretty scalable, and right now we just have one test door set up which leads to another room where you can go back to the original room, but it works decently. In the future, I want to be able to play specific sounds when you go in the door, such as maybe a staircase stepping sound, as well as other things that we might want to do, but for now, it works. As for the next things I want to work on, there's a lot of overworld object interactions that I wasn't able to show, simply because I ran into issues while testing, and so I'm gonna have to work on that, and that's something I want to show the next time that I see you. I also want to be able to refine this system, make it a lot easier and scalable, as well as finally make some prefabs for us to use around level. Moreover, I also want to add different states to the player state machine, such as falling, as well as enable pathfinding for enemies to be able to start battles. Moreover, I think something that would be cool would be able to have NPCs in our interactable class, though that would require pathfinding, which I'll have to figure out. In addition, thank you so much for the support on the last video. Your views, likes, subscriptions, and comments were really sweet, and we really appreciate the support, and it helps motivate us to keep going. One last thing I want to mention is that by the time this video is coming out, and by the time that I'm recording this video actually, a Substack post made by Olive that recaps last video, as well as includes some details that we weren't able to talk about last week, is now up for you to read. You can go to the post in our community tab in order to see it, or it'll be linked in the description of this video. Feel free to check it out. There's some pixel art that you haven't seen yet, though they're mostly assets, but it's a pretty cool read, and Olive put a lot of work into it. Thank you so much for watching. I'll see you next time, and goodbye.